This is Calculus 2 Exam 2 Review Detailed Solution. In this exam review, we'll cover mostly integral applications, area between the curves, and we'll cover volume by slicing method and volume by cylindrical shell method. And we'll cover area of surface of revolution, and we'll cover arc length and center of mass, which is centroid of a region. We'll show some show and tell animation of volume of slices method, and we'll show also some show and tell animation of surface area of revolution. These are some beautiful mathematics images or animations. Of course, in this review we'll cover area of surface of revolution, and those are examples. Area between curves, these are examples. Volume by slicing method, or is called also washer disk method. So those are the washers, the disks. Then we'll also show volume by cylindrical shell method, this is cylindrical shell method. Again, we'll show some show and tell animation of volume of revolution and surface area of revolution. I'll show these 5 animations. Again, this is Calculus 2 Exam 2 review. It is a review in addition to your professor instructor exam review. It is good review or tutorial for students in engineering Calculus 2, Calculus 3, Calculus 1, Business Calculus, and the AB Calculus, that is a high school. Also watch my Calculus 1 Exam 2 review and Business Calculus Exam 2 review, Business Math Exam 2 review, Trigonometry Exam 2 review, College Algebra Exam 2 review, Development Math Exam 2 review. I'm sharing this with you only as additional help, in addition to your professor instructor exam test review, which should be your main essential review. Number 1 is find the area of the shaded region. So figure is given and the shaded region is this, and the curve is, the shaded region is between x equals e to the y, that is the right curve, and the x equals y squared minus 2, that is the left curve, and from y equals minus 1 to y equals 1. So that's the region. So the right region is x equals e to the y, the left region is x equals y squared minus 2. And the area is from a to b, integration from a to b, right minus left dy, which is from minus 1 to 1 e to the y, that's the right curve, minus y squared minus 2 dy, which is from minus 1 to 1 e to the y minus y squared plus 2 dy, which is e to the y minus y cubed over 3 plus 2y, which is from minus 1 to 1. That is e to the 1 minus 1 to the third over 3 plus 2 times 1 minus e to the minus 1 minus 2 minus 1 to the third over 3 plus 2 times minus 1, which is e minus 1/3 plus 2 minus 1 over e plus minus 1 over 3 plus 2, which is e minus 1 over e plus 4 minus 2 over 3. which is E minus 1 over E plus 12 minus 2 over 3, which is E minus 1 over E plus 10 over 3. And that is the area between these curves. Number 2 is sketch the region enclosed by the curve y equals sine x, y equals 2 minus sine x, where x is between pi and 2 pi, and find its area. So the region is y equals sine x is the bottom curve, and y equals 2 minus sine x is the top curve. It is minus sine x shifted up vertically by 2. And we are finding the area between pi and 2 pi. So the area is integration from a to b, top curve minus bottom curve dx, which is a to b. A is pi to 2 pi. Then it is top curve is 2 minus sine x minus the bottom curve is minus sine x dx, which is pi to 2 pi, 2 minus 2 sine x, which is, when you integrate, this is 2x minus 2, the integration of sine is minus cosine x. That's from pi to 2 pi, which is 2x plus 2 cosine x from pi to 2 pi, which is 2 times 2 pi plus 2 cosine 2 pi minus 2 times pi plus 2 cosine pi, which is 4 pi plus 2 times 1, cosine 2 pi is 1, minus 2 pi plus 2 times minus 1, cosine of pi is minus 1. So that is 4 pi plus 2 minus 2 pi plus 2, which is 2 pi plus 4. Number 3 is find the volume of the solid obtained by rotating the region bounded by the curve y equals x cubed and y equals x, where x is greater or equal to 0, about the x-axis. So you're going to rotate this about the x-axis. Sketch the region, the solid, and the typical disk washer, and find the volume, of course. So the region is, the top curve is y equals x, the bottom curve is y equals x cubed, and that's, we are finding the region between these two curves. And they are rotating around the x-axis. So this is the rotation, and this is the volume we obtain, and this is the washer, the disk, and that's how it looks like. And we're going to show and tell the animation of this volume. So the volume is going to do the volume by slicing method, which is washer. So first find the AX of this washer. AX of this washer or this disk is pi r1 squared minus pi r2 squared, which is pi x squared minus pi x cubed squared. So that is pi x squared minus pi x to the 6, which is pi times x squared minus x to the 6. Then the volume of the washer is from A to B, AX dx. So that is from 0 to 1, 0 to 1 pi x squared minus x to the 6 dx, which is pi x to the third over 3 minus x to the 7 over 7 from 1 to 0, from 0 to 1, which is pi 1 to the third over 3 minus 1 to the 7 over 7 minus pi 0 to the third over 3 minus 0 to the 7 over 7, which is pi 1/3 minus 1/7 minus pi times 0, which is pi 7 minus 3 over 21 minus 0, which is 4 pi over 21. And that is the volume of the solid. Okay, so this is animation of volume of revolution. This animation is from Calculus 2, Exam 2 review. The first one is find the volume of the solid obtained by rotating the region bounded by the curve y equals x cubed and y equals x, where x is greater or equal to 0 and it is rotated about x-axis. So here is the top curve is y equals x, the bottom curve is y equals x cubed, and this is the region and it is rotated around the x-axis. And it forms this, so it is rotated around the x-axis, and this is the solid, the volume that is generated, okay? And that's how it looks like. And this is the animation that we're going to look at. So this animation has been designed. Okay, here is the first animation. Y equals x is the top curve, and y equals x cubed is the bottom curve. And it is rotated around the x-axis. The red is the x-axis, the green is the y-axis, and the blue is the z-axis. And here you go. As you can see, it's rotating around the x-axis. Okay, so let's remove the plane. Okay, so that was the first animation. Number 4 is the region enclosed by the curve x equals y minus y squared, which is this curve, and x equals 0, which is the x-axis, the y-axis, is rotated about the y-axis. So we're going to rotate, this is the region, we'll rotate it about the y-axis. Find the volume of the resulting solid. Sketch the region. So the radius of this solid, or this volume of revolution, is the radius of this disk or washer is r, which is x. And the x is equal to y minus y squared. So the disk area is ax equals pi r squared, which is pi x squared, and in terms of y, ay is pi times y minus y squared all squared. Then the volume is from a to b, integration from a to b ay dy, which is from 0 to 1 pi. Ay is y minus y squared all squared dy, which is from 0 to 1 pi y squared minus 2y cubed plus y to the 4 dy, which is pi y cubed over 3 minus 2y to the 4 over 4 minus plus y to the 5 over 5 from 0 to 1. That's when you integrated it. Then this is pi 1 to the 3rd over 3 minus 2, 1 to the 4th over 4 plus 1 to the 5th over 5th minus pi 0 to the 3rd over 3 minus 2, 0 to the 4 over 4 plus 0 to the 5 over 5, which is pi times 1/3 minus 2/4 plus 1 over 5 minus pi times 0, which is pi times 1/3 minus 1 over 2 plus 1 over 5, which is pi. Common denominator is 30, so that's 10 minus 15 plus 6, which is 16 minus 15, which is 1, so that's pi over 30. Number 5 is use the method of cylindrical shell to find the volume generated by rotating the region bounded by the curve y equals x squared, which is the bottom curve, and y equals 8 minus x squared, which is the top curve, and that is y equals minus x squared shifted up by 8. And we're going to rotate this about x equals 2 axis. And we're going to use cylindrical shell method here. That means we need the region. So A is sketch the region, which is this is the region, that's sketch. So the radius, we're going to need the radius. The radius is, since we are rotating it around x equals 2, then the radius is 2 minus x. So that's the radius. Then we're going to need the circumference. The circumference is 2 pi r, which is 2 pi, r is 2 minus x. Then we're going to need the height, which is f of x, which is the top curve minus the bottom curve, which is 8 minus x squared minus x squared, which is 8 minus 2x squared. Then the volume is integration from a to b, 2 pi r fx dx. That is the formula for integration by cylindrical shell. So that is a to b. A is minus 2 to 2 pi r is 2 minus x, and f of x is the height, which is 8 minus 2x squared dx. So that's from minus 2 to 2 pi times 2 minus x times 2, we can factor out from this 2, times 4 minus x squared dx, which is equal to integration from minus 2 to 2, 4 pi times 2 minus x times 4 minus x squared dx. We can factor out the 4 pi, then it is integration from minus 2 to 2, 2 minus x times 4 minus x squared dx, which is equal to 4 pi from minus 2 to 2, 8 minus 2x squared minus 4x plus x cubed dx, which is, when you integrate this is 4 pi 8x minus 2x to the third over 3 minus 4x squared over 2 plus x to the 4 over 4, evaluated from minus 2 to 2, which is 4 pi times 8x minus 2x cubed over 3 minus 2x squared plus x to the 4 over 4 from minus 2 to 2, which is 4 pi times 8 times 2 minus 2 to the times 2 to the third over 3 minus 2 squared plus 2 to the 4 over 4 minus 4 pi 8 times minus 2 minus 2 times minus 2 to the third over 3 minus 2 times minus 2 squared plus minus 2 to the 4 over 4. And when you do the rest of the details, this detail is arithmetic, then the volume is equal to 256 pi over 3. And we'll do this beautiful animation, but it is not related to the volume we just found. I just did animation around the y-axis. So it is this region, but it is animated around the y-axis. It is not the volume we found. So the animation is simple animation around the y-axis. Okay. The second animation is animation of volume of revolution again. Use the method of cylindrical shell to find the volume generated by rotating the region bounded by the curve y equals x squared and y equals 8 minus x squared about x equals 2. So this is the bottom curve is y equals x squared. The top curve is y equals 8 minus x squared. It is minus x squared shifted up by 8. Okay, and we're going to rotate this around the x equals 2. So that's the rotation, that's the axis of rotation. Okay, and this is the volume that is generated, and we'll look animation of this volume. Okay, the second animation is y equals x squared is the bottom curve, and y equals 8 minus x squared is the top curve, and it is about to rotate around the y-axis. The red is the x-axis, the green is the y-axis, and the blue is the z-axis. And here you go. Okay, so let's remove the plane. Okay, so that was the second animation. Number 6 is the region bounded by the curve x squared plus y minus 2 all squared equals 4 is rotated about y-axis. Find the volume of the resulting solid by any method. So sketch the region. So the region is x squared plus y minus 2 all squared equals 4. That is a circle centered at 0, 2, and it is a radius of 2. And when you rotate this around the y-axis, you find this sphere. So this sphere is integrated from bottom to top. All these disc washers, we find the area of these washers and we add them all together to find the volume. And we're going to do show and tell animation of this sphere. So First, we need to find the radius. The radius is r equals x. So that's the x. And in terms of y, it is square root of 4 minus y minus 2 all squared. Okay. So then the disk area AX is pi r squared, which is pi x squared. In terms of y, it is pi times 4 minus y minus 2 all squared. When you square this, it comes out of the square root. Then the volume is integration from a to b ay dy, which is integration from 0 to 4, which is from the bottom to top, pi 4 minus y minus 2 all squared dy, which is, you can factor out the pi, it is 0 to 4, 4 minus y squared minus 4y plus 4 dy, which is pi from 0 to 4, 4 minus y squared plus 4y minus 4 dy, which is pi from 0 to 4, 4y minus y squared dy. Then when you integrate this, it is equal to pi 4y squared over 2 minus y cubed over 3 from 0 to 4, evaluated from 0 to 4, which is pi 2y squared minus y cubed over 3 from 0 to 4, which is pi 2 times 4 squared minus 4 cubed over 3 minus pi 2 times 0 squared minus 0 cubed over 3, which is equal to pi 32 minus 64 over 3 minus pi times 0, which is pi times 96 over 96 minus 64 over 3 minus 0, which is 32 pi over 3. And that is the volume of this sphere. The next animation is animation of volume of revolution again. The region bounded by the curve x squared plus y minus x minus 2 all squared equals 4 is rotated about the y-axis. So this is obviously, it is a circle centered at 0, 2, and it is radius 2. And when you rotate this around the y-axis, you obtain the sphere. And this sphere is the animation of this sphere. We look at it is around the y-axis, and we'll look at this animation. So the third animation, y equals square root of 4 minus x squared plus 2, y equals minus square root of 4 minus x squared plus 2, and that is a circle. Okay, and the rotation is around the y-axis. Again, the red is the x-axis, the green is the y-axis, and the blue is the z-axis. And here you go. Okay, you can see it is around the y-axis. So let's remove the plane. Okay, so that was the third animation. Number 7 is a steady wind blows a kite due to west. The kite's height above the ground from the horizontal position x equals 0 to x equals 50 is given by y equals 100 minus 1 over 20x minus 50 all squared. Find the distance traveled by the kite, and that is the arc length, basically. The arc length from 0 to 50, and that is the red dotted region. So, obviously, you can see this is a parabola, concave down parabola. It is shifted up vertically by 100 and is shifted to the right by 50. And we are finding the arc length from 0 to 50, which is the red dotted. So we're going to need to use table of integrals number 21, which is integration of square root of a squared plus u squared du equals u over 2 times square root of a squared plus u squared plus a over 2 ln u plus square root of a squared plus u squared plus c. We're going to use this formula to integrate this. First, we need to find dy by dx. dy by dx is the integration of this. So y is 100 minus 1 over 20x minus 50 squared. Then dy by dx is the integration of 100 is 0 minus 1 over 20 times 2x minus 50 times the derivative of the inside, which is 1. So this is equal to minus 1 over 10 times x minus 50. So that's dy by dx. Then we need to find y plus dy by dx squared, which is 1 plus dy by dx is minus 1 over 10 times x minus 50 all squared. When you square the negative, it becomes positive, so this is 1 plus 1 over 10x minus 50 all squared. Then the arc length, the formula is L equals integration from a to b square root of 1 plus dy by dx squared dx, which is equal to 0 to 50 square root of 1 plus dy by dx is 1 over 10 times x minus 50 squared dx. So now we're going to call this x minus 50 over 10 is u. Then du is dx over 10. That means dx is 10 du. So then this is integration of from c to d 1 plus this is u, so that's 1 plus u squared du. So that is 10. We're going to use this formula, 10 u over 2 plus a is 1, so that's 1 squared plus u squared plus 1 over 2 ln u square root of 1 plus u squared. So that is equal to 10, but u is x minus 50 over 10, so this is x minus 50 over 10 times 2, which is x minus 50 over 20, square root of 1 plus u is x minus 50 squared over 10 squared, which is 100, plus 1 over 2 ln x minus 50 over 10 plus square root of 1 plus x minus 50 squared over 100. And that's integrated, evaluated from 0 to 50, which is equal to 10, 50 minus 50 over 20 square root of 1 plus 50 minus 50 over square root over 100. Notice this is 0, this is 0. okay, plus 1 over 2 ln 50 minus 50 over 10, which is, this is also 0, plus square root of 1 plus 50 minus 50 square root over 100, which this one is also 0, minus 10, 0 minus 50 over 20, square root of 1 plus 0 minus 50 square root over 100 plus 1 over 2 ln 0 minus 50 over 10 plus square root of 1 plus 0 minus 50 square root over 100, which is equal to 10 times 0 over 20 square root of 1 plus 0 square root over 100 plus 1 over 2 ln 0 over 10 plus square root of 1 plus 0 square root over 10 minus 10 times minus 50 over 20 square root of 1 plus minus 50 square root over 100 plus 1 over 2 ln minus 50 over 10 plus square root of 1 plus minus square root of 50 square root over 100. When you do the rest of the arithmetic, this is detailed arithmetic, you will end up with the arc length is 25 square root of 6 minus 5 ln square root of 26 minus 5, and that is the arc length, or the distance traveled by the kite from x equals 0 to x equals 50. Number 8 is find the exact area of the surface obtained by rotating the curve y equals square root of 1 minus e to the x, where x is between minus 5 and 0 about x-axis. This is area of surface of revolution, and the curve is this curve y equals square root of 1 minus e to the x, and we are rotating this around the x-axis, and this is the we are finding the surface area of this volume. Okay, so the first thing is we need dy by dx, so y is square root of 1 minus e to the x, then dy by dx is 1 over square root of 1 minus e to the x times minus e to the x. So then we need square root of 1 plus dy by dx squared, which is square root of 1 plus minus e to the x over 2 square root of 1 minus e to the x all squared. That is equal to 1 plus e to the 2x over 4 times 1 minus e to the x, which is square root of 4 times 1 minus e to the x plus e to the 2x over 4 times 1 minus e to the x, which is equal to square root of e to the 2x plus minus 4e to the x plus 4 over 4 times 1 minus e to the x, which is equal to, this can be factored into e to the x minus 2 times e to the x minus 2, which is e to the x minus 2 squared over 4 times 1 minus e to the x. Thus, this can be split into square root of e to the x minus 2 all squared over square root of 4 1 minus e to the x. And this is square root of squared is just e to the x minus 2 over square root of 4 is 2 square root of 1 minus e to the x. Then the surface area is equal to S from A to B 2 pi y square root of 1 plus dy by dx all squared dx. So that is equal to, you can factor out the 2 pi from minus 5 to 0. Y is square root of 1 minus e to the x, and this whole thing 1 plus square root of 1 plus dy by dx squared is equal to e to the x minus 2 over 2 square root of 1 minus e to the x. So 1 square root of 1 minus e to the x cancels the square root of 1 minus e to the x. Then this is equal to, the 2 cancels the 2, then this is pi from minus 5 to 0 e to the x minus 2. Then this is the integration of this is e to the x minus 2x from minus 5 to 0, which is pi e to the 0 minus 0 minus e to the minus 5 plus 10, which is pi 1 e to the 0 is 1 minus e to the minus 5 minus 10, which is pi times minus 9 minus e to the minus 5. And that is the surface area of revolution. The next animation is area of surface of revolution. Find the exact area of the surface obtained by rotating y equals square root of 1 minus e to the x, where x is between minus 5 and 0, and it's rotated around the x-axis. So that is y equals square root of 1 minus e to the x, and we're going to rotate this around the x-axis. And this is the volume that is generated, the surface area, and we'll look at the animation of this. Animation is y equals square root of 1 minus e to the x, where x is between minus 5 and 0. And it is, the animation is around the x-axis. Again, the red is the x-axis, the green is the y-axis, and the blue is the z-axis. And here you go. Okay, so let's remove the plane. And that's the animation. Number 9 is the curve y equals 1 over 2x squared minus 1 over 4 ln x, where x is between 0 and 3, is rotated about y-axis. Find the area of the resulting surface. So we are rotating this curve around the y-axis, and we are finding the surface area of this revolution. So first we need dy by dx. So y is 1 over 2x squared minus 1 over 4 ln x. Then dy by dx is 1 over 2 times 2x minus 1 over 4 times 1 over x, which is dy by dx is x minus 1 over 4x. So then we need square root of 1 plus dy by dx squared, which is square root of 1 plus x minus 1 over 4x squared, which is equal to square root of 1 plus x squared minus 1 over 4x times x minus 1 over 4x times x plus 1 over 4x squared, which is equal to 1 plus x squared minus 1 over 4 minus 1 over 4 plus 1 over 4x squared, which is equal to square root of x squared plus 1 minus half plus 1 over 4x squared, which is equal to square root of x squared plus half plus 1 over 4x squared, which this can be factored as x plus 1 over 4x times x times plus 1 over 4x, which is x plus 1 over 4x all squared. Then square root of that is just x plus 1 over 4x. Then the surface area is from a to b, integration from a to b 2 pi x square root of 1 plus dy by dx squared dx, which is equal to 2, you can factor out 2 pi and 0 to 3 x times this 1 plus dy by dx squared, all square root of that is, we found it here, it is x plus 1 over 4x. So that is dx, so that is 2 pi from 0 to 3 x squared plus 1 over 4 dx, which is 2 pi, when you integrate, this is x cubed over 3 plus 1 over 4x from 0 to 3, which is 2 pi x cubed, 3 cubed over 3 plus 1 over 4 times 3 minus 2 pi times 0 to the third over 3 plus 1 over 4 to the 0 times 0, which is 2 pi times 27 over 3 plus 3 over 4 minus 2 pi times 0, which is equal to 2 pi times 9 plus 3 over 4, which is 2 pi 36 plus 3 over 4, which is 2 pi 39 over 4, which is 39 pi over 2. And that is the surface area of the revolution. The next animation is animation of surface of revolution, area of surface of revolution. Area of the surface of revolution, the curve y equals 1 over 2x squared minus 1 over 4 ln x, where x is between 0 and 3, is rotated about the y-axis. Find the area of the resulting surface. So that is y equals half x squared minus 1 over 4 ln x, and you're going to rotate this around the y-axis. And this is the volume that is generated, and we'll look this animation. This animation is y equals half x squared minus 1 over 4 ln x, and that is the curve, and it is about to rotate around the y-axis. Again, the red is the x-axis, the green is the y-axis, and the blue is the z-axis. Okay, and here you go. Again, it is rotating around the y-axis. Okay, so let's remove the plane. Then number 10 is find the center of the region bounded by the curve y equals 2 minus x squared and y equals x, which is these are the two curves. So the top curve is minus x squared shifted up by 2 vertically, and the second curve is just the linear function y equals x. And we're going to find the center of mass, which is called the centroid of this region, of the shaded region. First, we need to find the intersecting point of these two curves. So the intersecting points are when these two curves are equal. This is the intersecting point, is this point and this point. We need to find this point, the x value of this point. So that is x equals 2 minus x squared, which is x squared plus x minus 2 equals 0. This can be factored, that's x plus 2 times x minus 1. This is equal to 0. Then this is x plus 2 equal to 0, or x minus 1 equal to 0. That is x equals minus 2, that is A, and x equals 1, that is B. So that is A, that is B, and it is integrated from A to B. Then we need to find the area of enclosed region, the area of this, and the area is integration from A to B, the top curve minus the bottom curve dx. That is integrated from minus 2 to 1, 2 minus x squared, the top curve, minus x dx, which is 2x minus x cubed over 3 minus x squared over 2, integrated from minus 2 to 1, which is 2 times 1 minus 1 to the third over 3 minus 1 squared over 2, minus 2 times minus 2 minus minus 2 cubed over 3 minus 2 squared over 2, which is 2 minus 1/3 minus 1 over 2 minus 4 plus 8 over 3 minus 4 over 2. And that is 2 minus 1/3 minus 1 over 2 plus 4 minus 8 over 3 plus 2. Which is equal to 8 minus half minus 9 over 3 minus equals 8 minus 3 minus half, which is 5 minus half, which is 10 minus 1 over 2, which is 9 over 2. Then we need to find the center of region, the centroid of region, which is center of mass, and that's x bar y bar. To find that, x bar is 1 over a integration from a to b x f of x dx. 1 over a is 9 over 2, 1 over a is 2 over 9. From minus 2 to 1, x times f of x is the top curve minus the bottom curve, which is 2 minus x squared and minus x dx, which is 2 over 9, integration from minus 2 to 2, 2x minus x cubed cubed minus x squared dx, which is 2 over 9, 2 times x squared over 2 minus x to the 4 over 4 minus x to the third over 3, evaluated from minus 2 to 1, which is 2 over 9 x squared minus x to the 4 over 4 minus x to the third over 3, evaluated from minus 2 to 1, which is 2 over 9 times 1 squared minus 1 to the 4 over 4 minus 1 to the third over 3 minus 2 over 9 minus 2 squared minus 2 to the 4 over 4 minus 2 to the third over 3. Then when you evaluate the rest of the detailed arithmetic, you will end up with x bar equals minus half. So that is x bar is minus half. Then y bar is equal to 1 over a integrated from a to b 1 over 2 f of x squared dx. Notice they are not similar. So one of them is f of x dx, the other one is 1 over 2 f of x squared dx. So they are different. So this is 1 over a times 1 over 2 integrate from a to b f of x squared dx. 1 over a is 2 over 9 times 1 over 2 from a to b f of x squared dx. So this is 1 over 9 from a to b. F of x squared is the top curve squared minus the bottom curve squared, which is 1 over 9 from minus 2 to 1. The top curve is 2 minus x squared all squared minus x squared dx, which is 1 over 9 from minus 2 to 1. This is 4 minus 4x squared plus x to the 4 minus x squared dx, which is 1 over 9 from evaluated from minus 1 to 1 x to the 4 minus 5x squared plus 4 dx, which is 1 over 9 x to the 5 over 5 minus 5x cubed over 3 plus 4x from minus 2 to 1, which is 1 over 9 times 1 to the 5th over 5 minus 5 times 1 to the 3rd over 3 plus 5 times 1 minus 1 over 9 minus 2 to the 5th over 5 minus 5 minus 2 to the 3rd over 3 plus 5 plus 4 times minus 2. Then when you evaluate the rest of the arithmetic, you will end up with y bar equals 2 over 5. And that is the center of mass or centroid of the region. This is also an application of university physics application. It is integral calculus. You probably will see this question in your physics class. And thank you. Please subscribe, share, and like. And ask your friends to subscribe, share, and like.